Hey there, trigonomaniacs. Let's take out our trigonometers and get triggy with it. We're going to use the law of cosines to find the cosine of theta. Clearly you remember the law of cosines, especially the version that we use to find angles. Cosine of angle C, so I think of this as angle C, and then across from that is going to be little side C, side little c. And then either one of these could be A or B. It really doesn't matter which one's which, as long as C is the side opposite the angle that we're concerned with. So cosine of theta is equal to a squared plus b squared minus c squared over 2ab. So this will be my A, this will be my B, or this could be my A, this could be my B. It doesn't matter because of the commutative property of awesomeness. So 6.1 squared plus 7.9 squared minus, this is the important one, that I have this one being the subtracted one, c squared, 4.9 squared over 2ab. 2 times 6.1 times 7.9er. So cosine theta equals, and then I am going to break out Mr. Calculator here. Come on, Mr. Calculator. Let's calculate. So for my numerator, 6.1 squared plus 7.9 squared minus 4.9 squared, close my numerator, divide by my denominator, 2 times 6.1 times 7.9er, close my denominator, and execute, and I get 0.7844988 blah 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 blah. Now, is this the exact value of cosine of theta? No, it's a decimal approximation. This decimal goes on forever and ever and ever and ever, but your calculator can only show you so much because it has a finite screen. So it rounds it to a bunch of decimal places. And then if we look at our answers, we were looking for cosine theta, and we have cosine theta equals this. And so let's see which one we're equal to. Hey, look, we're closest to C. Now we're going to use the law of cosines to find theta. So this is the same triangle. So remember, we had this for cosine of theta. So to find theta, we need to do the inverse cosine. So cosine, the inverse cosine of the cosine of theta will just give us theta. And so if we do the inverse cosine of the left side, we need to do the inverse cosine of the right side. And let me bring my good friend Mr. Calculator back on board. Now I've already got this number up here, so what I'm going to do is second inverse cosine, and then I'm going to use my arrow to go up here and grab that guy, hit enter. Inverse cosine of that guy equals 0.6689 something something something. Let's see. Now that looks like B. And then here I need to check, right? Am I in degrees or am I in radians? Look at my answers. Do I have any little degree circles? No. That means I must be in radians. So I check my calculator to make sure I'm in radians. Boom, shakalaka, I'm in radians. So 0.67 is going to be yonder answer. Suppose a triangle has two sides of length 4.2 and 8.7, and that the angle between them is pi over 3. What is the length of the other side of the triangle? Alright, well, In addition to supposing this triangle, I'm also going to draw this triangle. Say this is 4.2, and then 8.7 is longer than that. That is my perfectly awesome triangle with absolutely straight sides. The angle between those two sides is pi over 3. So, what do I do? What do I do? And I want to find what is the length of the other side of the triangle. I want to find this guy. So I might think about calling him C, or anything really that you want. And here is my formula. And if I was to take the square root of both sides of this formula, I would get what C equals. The square root of a squared plus b squared minus 2ab cosine angle opposite the side we're looking for. Okay, here's the side we're looking for. Here's the angle opposite that side. Here's my A, here's my B. Here's my angle C. So I'm ready to go. I just need to punch this in my calculator. Well, let me write out ever so quickly what it is I'm going to write into punch into my calculator. C equals the square root of A squared. So 4.2 squared plus B squared, 8.7 squared, minus 2AB cosine angle C. So minus 2 times 4.2 times 8.7 times cosine of pi over 3. Now pi over 3 is in radians, so I need to make sure that my calculator is in radians, which it is, radian. So I'm going to do square root 4.2 squared plus 8.7 squared minus 2 times 4.2 times 8.7 cosine of pi over 3. Ding. Then I'm going to push enter, and it's going to tell me 7.53 stuff, which I believe would round to 7.5. And it does. That's comforting. Use the law of sines to find A. Alright, well the law of sines is, if we're finding A, I'm going to put the A on top. So A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. And what do I have? I have angle A, I have angle C, I have side little b. So it would be nice if I had angle B. Gee, can I get it? Can I get it? Yes, I can, because a triangle has 180 degrees total. So if I do 180 minus 33.6 minus 29.3, that will give me the measure of angle B. So I'll get my low-tech calculator out and do 180 minus 33.6 minus 29.3. 117.1 is my measure of angle B. 117.1. 117.1. And see that little circle? That means degrees. Alright, so I'm setting this up. I've got my side B and my angle B, so that's going to be like my Rosetta Stone that unlocks all my other answers. So B is 85.5 over sine of 117.1 and I want to find A. So I'm going to do the A part over here. A over sine of, so now here's A, and then across from that is angle A. So sine of 33.6. Alright, now if I wanted to find A, I would just multiply both sides by sine of 33.6. So they will cancel over here, and I'll get A is 85.5 times sine of 33.6, these are degrees, divided by sine of 117.1 degrees. Now I'm going to bust out Mr. Calculator. Now I'm using degrees, so I need to go to degree mode. So mode, ga-bing, ga-boing, ga-bing. Hit enter. Now I'm on degrees. Quit. And now I can do 85.5 times the sine of 33.6 divided by, and since I've only really have one value on the bottom, I don't need to put parentheses to close my denominator off, divided by sine of 117.1, 53.15 would round to 53.2. Bing. Okay, tune back in for the rest, and that'd be awesome.